welcome to all students. And this is our second day of workshop. What do you know? So Utkarsh, I am. Are you here?
Yeah, I'm here. Hello, guys. Good evening. I'm Utkarsh Srivastav again,
Utkarsh.
and I'm here for now teaching you the second day about the electronics workshop. So it's 7:10, I guess, right? So I think I should start this workshop. Okay, so let me present my screen.
So you all know Utkarsh Srivastava.
I think, can you confirm that presenting start?
Yeah, you present. Yeah,
Uh, and the voice and all, everything is clear, right?
Yes.
yeah, everything is clear. You can start.
Okay. So now we are just going to start our second day of workshop. So just give me a
Yeah,
sec. Okay.
yeah, yeah.
Uh, okay. So previous in the previous day, I think many of you attend that particular workshop. And in the today's session, our agenda is something else. Uh, in the day one, basically we covered different kind of boards and the part of that particular board like pins, pin diagram, and there are various parts are there like connector boards and DC pins and all. So first day is totally about something like theoretical session, right? And in today's session, what we are going to do, it's quite interesting, by the way, because in today's session, basically we are dealing with practical and practical life examples and all. So we will also learn about the new concept of coding. Okay, so yeah. So what is the flow of our today's workshop? So initially, I am going to tell you about some electronics component which is actually required you for making your projects and all. So many of components are present over here, and I will show you also and demonstrate each component and thing. And the second thing we are going to discuss in our workshop is operating a multimeter. Basically, as you know, if you are an electronic enthusiastic person, so multimeter is a thing which actually plays a very important role in your entire project journey and all. So we have to know. We will not spend more time over here, but yeah, I will tell you the how the things are working and how you can use a multimeter, how you can get the readings from it and all. Yeah. Then after and all, we will see about the Arduino IDE software. Arduino IDE software. What is the Arduino IDE? Basically, it's a software by which you can program your overall system, like over not the system, your project, your microcontroller and all. Here, many of students are also who don't have any access of any microcontroller and all. So what they did. So basically, in the online way, there's a lots of online simulator platforms are there. Okay, like a Tinkercad, like Circuit Studio, right? And Wakvi is quite popular nowadays. Okay, so these are basically uh, online simulation platforms. So we will see about it, and then we will start our basic code of blink LED. Not a blink LED. Now your basic main course starts over here. Now then after learning the basic code of blink, you will start learning how the programming basically helps to do several tasks on the microcontroller. parameters. We will also see like if statement, while statement, data types, and serial monitor. What's the serial monitor? And basically, in previous class, I told you about the serial communication and all, like UART, Universal Asynchronous Receiver Transmitter Protocol. So also we will see how we can communicate with Arduino, and some actuator. In the last of the class we will see of some actuators. Basically, what's the actuators? Actuators are kind of motors and the physical thing, physical not a sensor, it's like a device, we can say, which basically helps to provide a movement to your overall system. It would be a motor, it would be a hydraulic, everything else. So anything else? So we will start. Okay, so components in electronics. Now we're coming about the components in electronics. Many of you, I think, not familiar with the electronics components because there are some pupils who are basically from the data science, right? So in the data science background, I'm not expecting that your professor is going to teach about this like capacitor, resistors, and all. So, but yeah, in the workshop we need these things. So I will tell you about it. So see, this a kind of components are there in the electronics. The kind of component, like the first one is the resistor. What is the resistor? Basically, resistor is a device which basically resists the current for to flowing. Okay, means resistor, like I will tell you 1 minute. Yeah, in the engineering, in the, sorry, symbol is something like that. Okay, and when current enters from this terminal, okay. So what the work of resistor? Basically, resistors resist the current to flow in particular direction. So there's a kind of resistors are there, like from 1 ohm to not one ohm, not ideal, but yeah, I'm telling you like 110, 120 ohms, like 180 ohm, 330 ohms. A series of like bunch of resistors are present over here. So we are not spending more time because we have to focus our main motto. So yeah, this is a resistors where basically you know that 1 minute. Yeah. Now the second thing is the capacitor. You can see over there. This is a capacitor. Basically, capacitor is a device which store electrical energy in the form of basically electric field. Right? The symbol of a capacitor is something like that. Two ways. Okay, the plus and negative. Basically, in the market, you will get two different type of capacitors. One is polar, and the second one is non-polar. Means there's no polarity, and first one has a polarity. So we will discuss it. And what's the work of this capacitor? Basically, it stores the electrical energy. Okay, it is something similar like a battery. Like battery, what happens? You plugged in a plugged with your battery, plug your battery with the charger. So what happens? Chargers give a charge and the battery will charge. Okay. The same thing happens in the capacitor when you give a voltage across these terminals. Okay. So what happens? Basically, it this voltage basically charge this capacitor. Okay. The charge store on this capacitor is denoted by Q, and which is equals to Q is C into V. C basically what's the value of capacitance, and the V basically tells about the what the voltage you applied over here, right? Yeah, it's a quite engineering term, so we are not entering in that. So like yeah, so diode are also there. Diode, what's the diode? The symbol of a diode is something like that. Okay, work. What's the work of the diode? Diode is a kind of thing which allows current to flow only in a single direction. Means if current wants to enter from this side, okay, so it will allow. Okay, so current can be moved from this one to this one. On the other hand, if a current wants to enter from opposite side, okay, the circuit is like the current flow from this side to this side, then diodes say no, you don't have access to these kinds of things. So basically it allows current in a one particular directions. Okay, the switches, like for turning on and off, there's a lots of switches like SPST switch, DIP switch and all, like light emitting diode, LED. You might have seen in your childhood. This was small kind of LEDs was present over there. Like you connect with the batteries and play with it. So yeah. So, and the inductors and the bridge rectifiers and the batteries, transistors, fuse, and loudspeaker, battery and all. Okay, so I will show you some components as well, so that you can get what. Okay, just give me a sec. Kshitish, can you pin this video where I'm going to show?
Yeah. Okay.
Can you just pin it?
Hey. Yeah. You are pinned.
No, no, no. I log in from the another device also. So
Okay, another device. Okay.
yeah, yeah.
Okay. Okay. Let me see.
Okay. The same name is there, Utkarsh.
Wait a minute. Yeah. Now you are pinned. You can start.
Okay. Thank you. Thank you. Okay. Okay, so we will start about the many of you know about these kinds of LEDs, like this is for LEDs and all, and transistors. Do you know about the transistors? What are the transistors and all? So you see the bunch of transistors present over there. Let me open it. Basically, transistors are acts as a switch in the uh, electrons. Yeah, you can see this is a small transistor. NPN transistor. Transistor basically are two types, like NPN and PN. So, basically, transistors and I told you about the capacitors. Right? So, see, these are the capacitors which present over there, right? And these are kind of MOSFET is another type of transistor. So these things are basically required you for making your projects and all. So one more thing is there like non-polar capacitors, which is also known as PF. The value of that PF is in some microfarad and all. So I will show you some of them. See, this is uh, 1 minute, 1 minute. I listen. I will stop here. Present it. Okay. I think now it will be clear, right? Okay. See, this is basically non-polar capacitor, and the same capacitors is this. This is polar capacitors. We will use in a different case now. So I will show you some more components and all. Now its main component is coming in the picture. The breadboard, where we are basically going to build or design or test our circuit. Okay, so make it clear. See, this is a basically breadboard. So I think many of you are familiar with breadboard. But I'm expecting that, starting from the beginning. So, see, it's a lots of pin over there. One, two, three, so lots of pin. So basically, what this pin will be, now it will be clearly visible. See, if you connect a particular LED, like I'm connecting LED in these two pins. Okay. Okay. So see, this LED is connected on the this pin. Okay. So okay. So this LED is connected on this particular pin, and the 1, 2, 3, 4, and 5. These pin are basically sorted. If you want to connect any wire, anything else to this LED, so just take a wire and place upon it. Simple. Okay. So these are connected, and here you will see the power rail. So total 10 basically columns are there. 1, 2, 3, 4, 5, 6, and 7. So five are basically joined. Means if you connect power supply here, so automatically from here to here, okay, automatically it will be present over here also. Okay, the same thing happens here. These 5 lines are connected, and these horizontal lines also connected, and these vertical lines connected. Okay, so this is the basically our breadboard, and these wires are known as the jumper wires and all. So yeah, these are the components, and yeah, now I will also tell about the multimeter. So what is the multimeter? Do you know, guys, what is the multimeter? Shorted means basically, yeah, I will explain it. Shorted means these are pins, these 5 pins are basically connected to each other. Sorted means these 5 pins are connected. Whatever supply as a short circuit, these 5 pins basically connected. Sorted means, okay. Yeah, it's a short circuit, we can say. Okay, no problem. Okay, so now I will introduce you to the multimeter. Okay. So in the market, there are many kinds of multimeter present. Like this is the most common one. Yeah. And the, some advanced versions of the multimeters also. See, I will tell you what is the use of multimeter and all. See, this is the, so I will start from this one. See, there is a knob present over here. Okay, let me show you. Right now it is basically on the off section. Okay. And you can say, you can see from here to here, it is showing that 600 volt to 200 volt, and a V is showing. Means if you want to measure DC voltage, okay. Remember, guys, DC voltage and AC voltage are separate. So you cannot measure the AC voltage in the range of DC voltage. If you are doing such kind of thing, then your multimeter will be damaged. So, okay. So this is the basically DC range. So here the values are showing like 600, 200. For example, if you want to measure voltage which is under the 20 volt, so just move it and place it in a 20 volt. And these are the props. So in the multimeter, basically, 1 minute, 3 points present over here. See, here it is showing the okay, V ohm and milliampere. That means if you are measuring the voltage and the resistance and the current which is under the 10 milliamperes, so you can connect this red prop on this. Okay. And there's a common, second option is the common. So this black wire always go on the common. And there's a 10 ampere DC. Okay, so this functionality basically used when we are measuring the current which is more than like 5, 6, 7 amperes of range. Not 6 is too high. I can say that 1 ampere and 2 ampere. If you're dealing in such kind of current, again I'm telling current, not a voltage. Okay. These are different. So basically, if you want to check voltage, you can connect over here. And also, if you want to measure the resistance and all, you can connect your multimeter in this range. Okay. See, like it is showing 200, 2K, 20K, and 2000. So means if you are measuring the resistance which value has 180 ohm, so we'll set it at 200. And if the value is above the 200 and below the 2K, so then set on this range. Okay. And for the current, you will use this range. So yeah, this is the basic overview of the multimeter. Now we will move forward to the start sharing the screen. 1 minute.
Yeah, hello, Utkarsh.
Yeah.
Hello.
Hello.
Y- Yeah, have you
So
done?
yeah, done. Now I'm going to start about the 1 minute. Sure.
Okay, I'm pinning your second screen.
Okay, please. So as I told you about the breadboard and all, now we will start the programming aspect of the microcontrollers. Basically, the most interesting aspect of the particular microcontroller and all. So give me a sec. I will just keep aside these things which I wanted with me. So, see, basically for the programming your microcontroller, the Arduino IDE is the software which generally we prefer. We can program this microcontroller from the other like HTMcube IDE and there's so many more other sites and all. Not a sites applications. So we can program it, but why Arduino IDE? Arduino IDE actually very simple, user friendly, and also it will largely support available. If you find any error and all, you can go on the Arduino CC form. There's a lots of questioning answer are there. They are actually very active on this particular thing. So we will start working on it, and those who want to make this programs and all these things online via simulation. So we will encourage you like use Tinkercad. Tinkercad. It is a software, not a software. It's an online site under the Autodesk. So it will basically provide you the interface for the learning Arduino and all. Okay. So yeah, now I will start with the Tinkercad. So I think screen is visual for everyone, right? Okay, sure. Okay, so when you log in it, there's a kind of interface over there. Just create a new project, do the circuit, and it will redirect you on the circuit. Okay, see. Now this is your overall interface. Okay, So this is your working area. Here you are basically put your components like Arduino and all. So firstly we will select the Arduino. It's okay. And now we are going to start our first blinking program. Okay. So take an LED. Okay. And this in the LEDs there are two terminals, anode and cathode. Basically, anode will respond for the positive terminal. So just click on it. You will get a wire. Okay. So like positive terminal. Okay. I will connect it. Okay. Let me connect it directly. Positive terminal with the 5 volt. Okay. And this negative terminal I will connect on the pin number 13. Okay, because it's a digital pin, so we can get 5 volt over there without any problem. Some It's not an ideal circuit because in the ideal circuit we must have to choose some current limiting resistance because the this LED will be operate on the 3.3 volt and all, so we have to uh, maintain the decorum like thing. So in the practical way, we also use a 220 ohm resistor, but yeah, it's a simulation we can do. So now we are going to start code. Okay. So here you can see the option showing the code. Click on it. Block coding. So this is for the very beginner and child level things. So now we are not doing this, and we will select the text option. We'll ask for the surety and all. See. It will automatically provide you a code. So I will just tell you about what is this. So basically it is C++ code. Okay. So firstly you will see this as a thing is written is the pin mode. What is the mean of pin mode? In the previous class I told you that in the Arduino there's a kind of pins over there, right? Digital pin 1, 2, 3, 4, 5, 6. So firstly you will tell to the Arduino that which pin you are going to use, right? If Arduino don't know the which pin you are going to use for your projects and how it will handle our task and all. So in the setup part, basically we set up the initial things. Okay, like there's a lots of thing over there, lots of thing there. We will discuss about it, but in the setup part, we will set up the things. See, and pin mode basically. What this function is pin mode? It takes two input. First is First is the pin number. Basically, LED built-in is a mark in the Arduino. So not using it because it. So first we will define that which pin we are going to use. Like here we use the 13 pin number. So we'll say okay 13 pin number using as a output because we are providing a output signal here, right? For the controlling the LED we are providing either 0 volt or 5 volt. So we will tell the Arduino like hey Arduino, this is my pin number 13 and I will use as a output pin. Means we cannot get the data from here. We are only providing a kind of signal over here, right? We are providing, not getting. So setup part basically in the programming, in the Arduino programming, this part runs only first time when you turn on your microcontroller, or run only first time. And then now the second thing is loop comes. Basically, loop what it did, it is a loop. Loop means these statements going to happen repeat again and again, again and again until you turn off your microcontroller. So after going the setup part, our microcontroller basically comes out in this range. Okay, and then do that particular things and all, do and do and do. So here what is the written? Digital write. Okay, so see the syntax over here. Basically, uh, so W is the capital and all this. If you write in the smaller letters, so it will make your syntax error. So be careful with that. So what is telling the LED bulletin? No. what I will do, digital write means I want to write a digital signal where on the pin number 13, basically what signal I want to write. See, for the blinking a LED, we have to provide two things. Like first is plus 5 volt and other is 0 volt ground. So we directly provide the plus 5 volt from the Arduino, right? See, it is connected. Now we will provide a ground signal, means 0 volt from the this particular 13 number pin. So yeah, LED will start glowing automatically, right? You don't have to do anything. So yeah, so what I will do, I will firstly provide a on the 13 number pin what, a low signal. Low means 0 volt, because in the digital systems, digital logic labels, there are only two logic labels are there, right? Is the first either high, either low. High means 5 volt, low means 0 volt, right? Now the function comes delay. What is the mean of delay? Basically, delay means, hey microcontroller, come here. Firstly, it will execute this step. Okay. When it's execute, it will provide a low and the LED will start glowing. Okay. Now delay function, what is take? It will tell to the microcontroller wait for 1000 millisecond, means 1 second. 1000 millisecond is equals to 1 millisecond. Means stop over here. Whatever you are doing now, just stop over here. So it will wait for 1 second. Then comes the digital write function. Then what we will do, means we, if we want to blink it, so that turn off it, right? Off and on, off and on. For the off this signal, what we can do, we can just give a high signal. Why? Because here also from this pin also getting the 5 volt, and this pin also getting the 5 volt. So if we are providing 5 volt at both sides, so what happens? So basically, if you are providing the 5 volt on the both sides, so voltage difference across these terminals will be same. And if the voltage difference is the same, there's no current flow. If there's no current flow, the LED will be not on. It's a turned off, right? So if we are start using, okay, so now we are going to start this simulation. Let's see what happens. No. Let me change it, because on the 13 number pin, now we are providing it high signal, right? It's high. See, and it will wait. Now the second is wait for the 1000 millisecond and just start simulating. Okay, see, it is start glowing, right? On, then off, on, then off, on, then off, on, off. See, and basically, if we increase this timing, like we want, it happens very quickly. Let me stop this simulation. Like if we change this to the 5, not a 500, like 400 milliseconds, so the timing will be 400. So now see what happens. So LED start blinking very fastly, right? See, it is happening, right? It start blinking very fast. And if we want to do any patterns and all, so we can also do it. But so 1 minute. Yeah. So if you want to glow LED alternatively, you can glow it. I will come forward. I will come on this topic also. So guys, I have a question that is this clear to all? Now basically we are going to show this particular experiment. Okay. I will repeat it when this particular experiment with your physical board. This is the simulator. Right. So I will start this code. Okay.
I have a question.
Sure.
You connected the LED from VCC to LED to the digital pin. So in that case, when you give high, the LED turns off. When you give low, the LED turns on. Why not connect it from digital pin to LED to ground?
Why not connected? No, no, no. We can connect, but I just do it randomly. You can connect also this one. Okay. So okay. So now, Kshitij, are you there?
Yeah.
Uh, Now basically I'm going to demonstrate this experiment by our 1 minute.
Hey, hey
One
Utkarsh.
minute. Huh? Okay. Yeah.
Hello. Could you please stop your screen share? Like
Okay.
students are saying they are seeing multiple screens, so that's why they're telling.
Okay. 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 So now they pin this video again, and I will demonstrate this experiment with the help of Arduino IDE. Okay.
Okay, I've pinned it.
Okay. 1 minute. One minute. So I will demonstrate the same experiment on Arduino IDE. Okay. So I think the screen is visible for all of you, right?
Yeah, screen is visible.
Okay. So I will just open the Arduino. Before opening, let me copy this particular sketch. Multi-screen is going on. See? So basically now I opened this Arduino IDE software. So the same thing over here, just like a white setup and white loop, and I will connect this board to the Arduino. So what the things we have to basically, one minute. Okay, in the menu here you find tool section. Okay, whenever you connect your Arduino with your laptop, so first you will check that it is connected or not. So in this tool section, you get a port option. Okay. Then you will check the COM14 is showing is Arduino. Okay. So firstly select upon this. Then select your board. What board basically you are using. Right now I have multiple boards, so let me close it. Select on, again I'm telling tools, and the board means which board you are basically going to use. Arduino AVR boards, select on Arduino AVR, you will get Arduino. Okay. Now the COM port is selected, means COM port basically sometimes you will get an error by finding your COM port. So you will basically get from device manager. I will tell you. Sometimes you might find error on which port it is connected. When you connect your Arduino, so it will show in your device manager section. You will see the port and COM options. See, it is showing the Arduino Uno and the COM port number is the 14. So, with the help of this, you can confirm that your Arduino is successfully connected with your laptop. Okay. So, now after checking it, we will confirm like it is a port 14 and the code is the Arduino Uno, and the same code I will upload over here. Oh, mistake. See, so now we will take a LED, this red LED, okay, and placing it. This is the first point. Take a jumper wire. Okay, and connect with positive pin of LED, and the second is second jumper, black jumper wire connect to the. Okay, so as the Soumya says, why you are not connecting in the, ground, so now I am again connecting it to the ground. Okay, as per their directions, and this particular second pin I will connect to the pin number 13. I think this is the pin. Basically, before connecting it, I will provide a, I will upload this code. This is the upload button. Okay. Pin number 13 is this. Okay. After uploading, you will see. It is, this LED is blinking, right? Let me see. Okay, if you want to change the timings and all, so I will also do it. Like if you want to blink it fast, and so I will set 200. Okay. 200. And firstly we will compile it. Okay, so this sign, like tick arrow is present over here, will basically told you that it's a compile button, and after successfully compilation we can upload it. Now it is uploading, and let's see, blinking speed is a change, right? Now it is blinking with the kind of speed. No, so this is our first project basically. Now we will move forward our second project. What comment is this? Okay, so I'm asking from you guys, is it clear for you? Means, are you getting or not? So we will move forward. Just show your reactions, guys. Okay, okay. See. Okay, so after the blinking program, I'm just going to tell you about the fading program. Means if you want to control the brightness of this LED, right? So how can you do it? Perform it? So basically, see, for the controlling the brightness of particular LED, we in previous class we know that there's a term called the PWM signal. So if you want to control the brightness of this LED, so you have to provide a PWM signal, like because the PWM signals basically provide a V average from the range of 0 to 5 volt, whatever range you want. Okay, so we will start modifying this code. And one more thing, like in this experiment, what we did, we used the pin number 13 for the output. But if we are using the fading program, so we'll get a problem. What is the problem? I will tell you. Let me open the slide. See, this is the pin number 13. Okay. And this is the pin number 13, which don't have any PWM pin. Not a pin which don't have any PWM access. Means this pin cannot provide a PWM signal. Okay, guys. So for the fading program, we cannot use the 13 number pin. We can use only those pins who has the access of the PWM. That means who can provide PWM signals. So in the Arduino, we have only 6 pins which can provide PWM, right? It's the 11th, either 11, either 10, either 9, 7, or like 5 and 3. So right now in this program, what we are going to use pin number 9. Okay, so if we want to change the pin, I just saw a comment which is asking about the changing the pin. So yeah, I will tell also this particular point. See, now we are using the 9 number pin as a output. Okay, and for the digital signals like 0 to 5, 0, either 0 or 5 volt, we are using the digital light function. But here, basically, what we are going to do, we are feeding. Feeding means firstly the LED will turn off, then it start glowing, and it will go there full capacity, then turn on. This is the fading basically. So, what we are going to do, remove this. That, so, okay. See, firstly I will use a loop. Why? I will tell you later why. I will switch to I will tell you it just by previous articles. See, for the fading, I will use this particular code. So I will explain you what's the mean. Firstly, I think I'm assuming that everyone knows like what is the loops and all in the programming because all of you are coming from the data science background and the electronic systems. So in the electronic systems, in the first term, you will learn about the C programming. So I think you know about. I'm expecting that, but I will tell you that for loop basically is a kind of loop. So what it did, firstly, it will initialize the integer I. Integer means it is a kind of data type which you handle in your programming and all. Integer data type basically variable is basically holds the integer values. Okay, like 0, 1, 2. It would be -1, -2. Okay. And the second thing is the condition. What is the condition is there? Like in the PWM signal, I told you like PWM signals, there's a kind of ranges, right? So basically in the PWM signal, let me show you. 1 minute. If it is a 5 volt, I am telling about the average values. Okay. This is not actually happening, but yeah, it's an average value. Basically, PWM signal makes an average something like that, right? So in the PWM signal, they did, took this particular area and split it into 255 parts. Not a 255, but 265. So 0, when you write 0, means if you tell to the Arduino like analog write function, basically, which corresponds for the PWM signals, which basically writes the PWM signals on the Arduino microcontroller pin. So if you provide a 0, then it will just provide a signal which is similar like 0 volt ground. If you provide 100, so it will provide a signal which is something like 1.5 and all. Okay. and not a 1.2, 1.5. Okay, you can say. If you provide 140 or 120, so 3.3 volt. So basically, they will split these signals in the form of 0 to 255. Okay, so 1 minute. So what it did, it firstly initialized the 0. Then a microcontroller did what did just make it 0. On the 13 number pin, it write a 0 voltage, and 1 minute. Oh, okay, because we are providing the ground. Okay. And the second, under the when it goes back again, then again add 1. Okay, I plus plus means add 1 and check the condition, and again it will provide that particular value. Now it's a 2, then 3, 4, 5, 6, and there's a delay, small delay over here, and this function is looping continuous. Just make a one more delay over here, like 2000, not a 2000, 1000. And let's see upload this code, what happens. No, mistake is there. I will change this to pin number 13, pin number 9. Okay. Pin number 9, and pin number 9. Firstly, we will compile this code. Now, uploading. Okay, let's change this particular pin. See, let me turn this light, then you can see clearly. It is increasing their brightness, and we start increasing. Then after some time, it will turn it off because it will take some time, because it is going to 255. So yeah, so turned off and again turn on. I think it is not, I can see that it is not very clear in camera, but yeah, right now I'm just seeing that it is very clear. Okay. So what I did, I will just do one thing more. Make a delay of 2000 seconds and just copy it. Okay. Okay. See, now what I did, basically when the compiler, the microcontrollers and exits from this particular code. So when it exits, uh, when the brightness value is 255, means the highest. Then what I did, I just write the 0 value, means the 0 volt, means the turn off the LED for the 2 seconds. So it would be more clearer for you. Okay, see. Now it is going. After the reaching full brightness, it turn off for the 2 seconds and just again turn off and we restart blinking. Not a blinking, it's a fading. In the online. Yeah, I think guys, can you tell me it is clear for you all? Clear or not? Okay, so this is the basic fading project. You can do it on this circuit wizard. But I'm not going to spend this thing again. Spend my time again on this particular website. So I will urge to you, like after this session, please try this code by your own with the help of this particular Tinkercad software. And
Hey, Utkarsh, I think they are asking for 255 part.
sorry, hello.
Yeah, in chat they are asking for part number 255. Like, why
Okay,
specifically 255 and not 100?
okay. Understood. They are asking that is basically why the 255 and not any other digit. Basically, it is designed by the Arduino company. Like they said that threshold value at 255. So yeah, it is predefined. So we cannot do anything on it. Right. And now we will move forward about our second, not the second, so third experiment. Okay. So what is our the third experiment? Now we are going to control this particular LED with the help of our just a minute. Okay. So what I'm telling that now I'm going to control this particular LED with the help of this serial monitor. Means using the serial or UART communication. Now we can control this LED. How? And this experiment will be very inter- it will be very interesting for you. So here you will see at the corner of the side, this thing is written serial monitor. Okay, when you press enter, so there is a kind of window open over here. This is the serial monitor. What is the serial monitor? Serial monitor basically when you are wanting to communicate with your Arduino with the help of your laptop and all with, using the UART technology, UART protocol. So this serial monitor will help you. Basically, you will send the data from here. You can send the data as well as you can receive the data from here. Okay. So like what I did, what we will do, like we will send a command for just on and off this particular LED with the help of our laptop. Okay. So the code will be like not the same. We have to make some changes like okay, then number thing is off. So let's see what we have. First, we will tell the microcontrollers, okay, hey microcontrollers, we are using your UART communication, means serial communication. So for the telling to the microcontrollers, the function is there, the serial dot begin. Okay. And inside the function, it will ask for the your baud rate, means what at what baud rate you are communicating with your computer. Okay. So right now we are using 900. So 900, not 9600 baud rate. Basically, you can use multiple baud rates. Here you will see there's a lots of baud rate are present. Okay. 300, 600, 750, 1200, like 49, lots of baud rate. So it is like a channel, like just in a radio. What happens like you are reading, not a reading, listening a radio on a particular channel, and then you move the channel comes. Yes, it is something like that. Okay. So firstly, we will tell the microcontroller we are using the serial communication. Okay. Then on the other way, we will read the data from the yeah, from the serial communication. Firstly, we will read now. Like what our goal is, if the data is if I am sending F character, so that means it will off my LED. Okay. And if I will send O character, so that means it will microcontroller will all on my LED. Okay. So we will deal with the two different characters. Okay. So firstly, we will check in the white loop. Firstly, we will check the serial communication is available or not. So we will write a code like if serial serial dot available. I will explain you each part. And then we are going to read. Basically, first what it did, it will check like serial communication is available or not. Means we are connected or not, something like that. If it's available, then available not a kind of one minute. Okay. So now we are basically going to read the data. Okay. After checking the connection is available, data is come or not. Now we are going to check our. So for the checking data, there is a function which is serial dot read. Yeah, serial dot read is the function basically which read data from your serial code. Okay. So let us see. So basically we are expecting a character type data, right? So what we will do, just declare a variable, char variable, and name is data. You know that what is the char? Char is the data type which basically store only those variable who has character in nature, right? Like A, B, C, D, small a, small b. Any integer will be character. Any like a specific symbol and all these are the characters. So what is the data? Data is a serial 1 minute dot read. Okay, we read the data, then compare. For the comparing, you know that we basically use if statement. So data is equals to means first condition on, right? So what we will did, we check that if the letter is O, like O, then it will enter inside the if. So what we if it is O, then what is our motto? Our motto is the LED should be turned off. Turned on. So for the turning on the LED, uh, basically which signal we have to provide? Ground is already yeah there. We have to provide plus 5 volt, right? So plus 5 volt we can easily provide using digital signals. We don't have to use any analog signal, analog like PWM, digital. So digital right, we will use digital right function. It will ask about the pin number. Basically, I used 9th number pin for the LEDs and 9 number pin. And what we are going to provide is the high value, means the plus 5. Okay. And for the off condition, if we want to turn off, what we will do? Just change it to the F. Okay, this F small letter if comes, then it will low. And if it is low, so what happens? If it is low, so basically both terminals will be low, potential will be same, then the no current will flow and the LED will be turned off. So let us check again. Yeah, everything is okay. First compile it. Now I'm going to upload this to. Okay. So now code is uploaded and the LED right now is off. So I will open the serial monitor. First, select the baud rate, because if you are communicating with different baud rates, so it will not happen. So see what baud rate you are using here, and the same will be here. Okay. Now I am sending the data for on. Let O for the on. When I just send the data, what happens? See, LED start, and I just send the data F. I think it is visible, right? I'll do it bigger. See, previously I sent O for the on, and then now F for the turning off. It is off. Then O, again if you want to turn on, then send O to start. And if you want to off, just off. See how easy it is. And we can do something more. Like if you want to show this status, like right now LED is on and off, so we can also do such kind of things. How? I will explain. Like for the printing on your serial monitor, like now, first in the first case, what you did, you send the data from your PC to the microcontroller, and now you are basically getting a data from the microcontroller to your PC. So how it is happening? So see, this function is known as serial dot print ln. ln means for the new line. Okay. So when O pressed, so LED will be on, and also status will be shown as LED is on, right? So LED and the same thing is happening over here. Now LED will be off. See, now what is happening here? When you press O, the O data will go in the microcontroller. Okay, and the microcontroller will read and see. Okay, now the data is O. Then write on 9th number pin as a 5 volt, and now Arduino will respond to you. Means send us message to you. Okay, now LED is on. Means whatever you are writing inside this, it will send by Arduino. Okay, it will print on your screen. So and the same case is there. It's on and off. And if we again compile it and just upload it, okay. So right now it is off. I press O and enter. LED is on. See, there's a message also there. It is showing that okay, now your LED is on. If you want to off it, just press O and enter. Sorry, F. Enter. Now LED is off. Also message you are getting. If you want to on, enter, F, enter. So by this way you can easily do such kind of thing. Okay, now I have one more idea. Like if you want to make a fade also, means if I'm send like A, okay, if I send a data in A as A, so what it did, it start fading the LED, like as we did previously. So we can also do it like if data is equal to A. Okay. Be careful, sir. Double equal to is there. Basically, sir, comparator, operator, right? So logical operators are there. So be careful on not a single equal to. Okay. And data will be A. Okay. Now what happens? Now I want to fade it, right? So for the fading, we basically write this particular program also. just copy it. Paste over there. Okay. See, now the same thing happening over here as we did in previous. If the data is A, then it will enter inside this loop, and it will write an analog, right? Means now it requires the PWM signal for the feeding it, right? And doing the same thing, and okay. And then 0, and for the delay it's a 2. Let me compile it. Okay, it's successfully compiled. That means there's no problem in our code. So then we will upload it and check. Just uploading. For the on, I'm again pressing O. It's the on, off, and now if I'm pressing A, it starts fading. Right? Off. Again, if I want to fade again, then again here, it starts fading. Okay. For the continuous fading, if anyone asks me about the continuous fading, so we will change it to while, so it will act as a continuous fading. But this is not a topic. And yeah, this is overall the project. One thing I have to do, just telling the status what the currently status is, like fading, so delay for the 10 seconds, and log right. Serial dot print ln. Okay, what message we are basically expecting to show? Like okay, fading is on, right? Fading is on. Okay. So now what will happen? Now it will indicate on your serial plotter, not a plot, it's a monitor. On your serial monitor, okay, the fading is on. So just re-upload it. For the on, I will press O, on, off, press F, and the fading, I will press A. See, the fading is on, the message is there. Like maybe not is a bit more. Like if I'm giving A, just fading and start fading also. Right? Something like that. So this is the so guys, I think it would be helpful for you. Are you getting these points or not? Please can you tell me? Okay.
Yes, it's clear.
One, yeah. Yeah, sure. Tell me. Ask me. Hello.
I just said it's unclear. It's I understood.
Okay, 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 good, good, good. So I the same. Okay, I will tell you. You can do same things easily. Okay, one of project I will show you. Okay, see, one, I will just reconnect it to the pin number 9 because pin number 9 has PWM. Right? On the code, I'm not using this particular code. Take our code, let's copy it. Okay, Tinkercad I will paste it. Okay, this is my code basically, which I told you how it is working and all. So again, I will start and one more change is there because I'm providing high signal. So I will change this to the ground. Okay, this is code and I will start simulation. Okay, it is starting. So then at the last bottommost corner, you will see the serial monitor is present. Just click it. Now inbox is from here you can write whatever you want to write. Okay. For for the on, basically on the LED, we have to press O, right? Just press O. LED. Okay, okay. One more thing. Actually, I changed the wirings and all because it is ground, so it will go into the cathode. Just give me a second. I will change the wire because the polarity has been reversed. This is the cathode. Okay. Okay. Now we will start simulation. I'll show just LEDs on. See, also we are getting the masses. Okay, and if we turn off this LED, we'll press F, and LED is off. Also, masses is there. And for the fading, I don't show that this function is available over there. Yeah, it is also there. Fading, fading also. So by this technique, you can easily get whatever you want. So yeah. So I will over to the page. Now he will carry out the Q&A sessions and all. So Kshitiz, are you there, bro?
Yeah, I'm here.
Okay, okay, good.
Okay, so I will pass down this session to Lavish. So Lavish, do you want to say anything? You can
Yeah,
proceed.
yes. I think
Okay,
thanks to
just
Utkarsh and I am audible.
yeah, you are audible.
So first of all, just thanks to Utkarsh and all the students. Without you, this wonderful session not possible. And I think today was a more on practicality session. Utkarsh, you anything you just say to students? Yeah, Utkarsh, you are not audible.
Yeah, actually, give me a 2 minutes of time. I will just arrange
Yeah,
these things
sure.
again. Okay, just two
Sure.
minutes. Okay, okay, then continue for the 2 minutes. I will be there.
Okay, I think it's time to end this session. Like,
Yeah, all thing are I
if,
think done.
okay, wait for 2 minutes. Like, Utkarsh, if he want to say anything, he can. So everyone enjoyed this session. Like, how do you feel about this? Uh, the
So,
reaction
guys,
has
are
been.
you basically getting the things or not? Just open your mic and tell me.
Yeah, sure. Give your feedback.
Amazing session, bro.
Yeah, give your feedback. It will basically very helpful for us for improving ourselves.
Okay, 1 second. I'm stall like. Shall I stop the streaming?
Yeah, you can.
Yeah.
Okay.
Yeah, yeah.
It's completed. Yeah, you can end this stream.
Okay. The like content
Ah,
part is done, right?
Yeah, sure.
Yeah, the
Okay.
content part is done. Now it's like chit chat time.
Q&A
Carry on,
session
guys.
like
Carry on.
this.
Carry on, guys.
Okay. So, guys, just tell me how was the session? Are you getting these points? Are you getting some new things or not?
So in my college, I
Amazing.
had a course which requires me to do a project out of conductors, like boards like this one, and this course is really helping me to do it pretty well. So yes, it's very helpful.
Okay. And
My
guys, if you
BTech
have any
also,
questions, sure. Continue.
in my BTech also mini project is going on, and we have to make some simulations over this by using of this Arduino. So it is very helpful for me. Thank you very much. Amazing session.
And if you have any questions and also you can directly
Yeah,
write in
you
the
have
comment
any
box
question?
also. We are just seeing this.
If
If
you
you
have
have
any
any,
questions, then we can extend this session to 5 to 10 minutes. You can ask any question if you want, or you can raise your hand or type your question in the chat. We will read them and answer. Utkarsh will answer those questions.
Okay, so I will urge to you all students that do practice these particular things on Tinkercad. Basically, if you are practicing these things, then you will actually learn. Because the self-learning is the very important part in the project making and all. Whenever, even if you are not touching the boards and not dealing with that, so I think it will not be beneficial to you. But yeah, you will do these particular tasks on your Tinkercad, and tomorrow also show me the results what you get and all. Okay, I think everyone has completed their doubts, so we can end this session. It's 8:30.
If you have if after this session you have any doubt, you can type it in the group, or we will read that and reply to you personally, or uh, we will DM you, or we will reply you in the group.
Yeah.
So everyone try to create everyone. Yeah, we will share the code
I will show.
after
Okay.
this session. We will share the code plus PPT and live recording of the session. I think recording part is done.
yeah.
Okay,
Okay.
Lavish, I think now it's time to end this session.
So I hope you guys all enjoy the second day of the Arduino workshop, and today is more based on the practicality. So thank to Utkarsh and all of your students. Without the of to you, the session was amazing with you guys. And the all things you need, the code and the PPT will share in the group, and stay connected with us for the all only. And
Okay.
Utkarsh,
So
anything?
thank you. Yeah. Okay. So thank you guys for
So
being here, and we'll meet you in the next session. And in the next session, maybe you will learn about the sensors. Okay, how the sensors you can deal with the sensors, and how you can connect sensors and get the data from it and do particular task on the basis of that particular data, right? So in the tomorrow session, you are basically going to learn about the sensors, and yeah, the tomorrow sessions also the practical things are also be there. So tomorrow session will be very interesting for you. So yeah, now I'm just
so
forwarding to
let's end the
Kshitij.
session, and thank you
Yeah,
everyone
Utkarsh.
for joining.
Okay.
So if you want to leave, you can. We are ending this meeting officially. We are officially ending this meeting. Okay.